So let's look at part 3. So part 3 is you're told that the benzene level of another 50 test chambers containing the indoor plant were recorded. The sample mean is X bar and the sample variance is 8.33. So this is important. I think many times students get confused of this part here. This is sample variance, meaning this is actually just sigma x 8.33. Okay, you're given the sample variance, so in other words, you need to find use this formula here, S squared is equals to n minus 1 sigma x squared. So unbiased estimate of population variance is actually n over n minus 1 sigma x squared sample mean. Okay, so unbiased estimate of population variance is equals to n over n minus 1 sample variance. Okay, so this is important. So typically this is something which students have problem understanding. So you have n is 50, so it's 50 over 50 minus 1. So because sample variance, so sigma square x, so sigma x square is 8.33. So just key in this and you'll get 8.5. Okay, now if you're confused, what you should do is you should try and understand and draw the diagram out. You are told that actually H now is mu. It's the same test hypothesis that you did for the first two parts. So H1 acceptance region of the test is where bar x more than 25.1. State the alternate hypothesis to find levels. Another sample mean, so this will be the same test which is less than 26.0. After which so just take note, the population is not distributed, is not told that it's distributed normally, but because since n is large, okay, basically under H0, the test statistic would just be z equals to x bar minus 26.0 over s square root n, which is actually, what's n? N is actually 50. Okay. And this will just be n0, okay, approximately this is important, this is by central limit theorem. So you have to use central limit theorem here. Okay, you have to. So since n is sufficiently large, since n is large, okay, so that's under H0. That's what you're gonna do. So what we're gonna do now is essentially try and understand that the acceptance region of a test is actually bar x more than 25.1. Okay, so state the alternative hypothesis and find the level of significance of the test. Alternative hypothesis, so we already state the alternative hypothesis, so meaning to say the alternative hypothesis is less than 26, right? Yeah, so let's try and understand what's going on here. We know that essentially this part here, the acceptance regions for H0 would be x bar here, which is 25.1. Okay, so H0 is true. Just remember that H0 is true. This one would be mu equals to 26.0, and x bar is actually equals to 26.0. After that, you use s square over 50. Okay, so this is the bar they're looking. So this is when H0 is true, is this side here. We essentially use this side here for H0 is true. Okay, this is H0 is true. Then what we want is actually find the significance level. Significance level would be this side here, right? So this side here, where this is our significance level. Okay, so that's H0 is show. This is where reject H now. So if this is a boundary, basically what you need to do is actually just find the area on this side less than this side here. Okay, you could actually just use your GC and just use normal distribution. There are many ways to do this. Some schools will tell you to just go back to the standardized curve, but actually if you understand the concept here, you could just use this part here, which is to 25.1, and mu is actually 26, and sigma is actually square root of s squared. So let me just 8.5. So I'm just gonna square root of 8.5 divided by 50. Okay, so this is 8.5 divided by 50. Yeah, so then we're just gonna paste this and just press enter. So this would be level of significance of a test would be 0.01452. So level of significance, let me just write this down. From GC, level of significance is equals to P bar X less than 25.1. So yeah, and after which I'm just gonna do this as 0.01452, 0.01454. Hence 1.45%. Okay, so that's how you do this third part here properly.